Greetings, welcome to this video. So we want to look at how we can plot the sets on a number line. So let's go ahead and look at a few examples, and much of the examples that we used in this video have been picked from MAT1120. But let's look at how we can plot these sets on a number line. So let's say, for instance, we're given a set, let's say set X to be our universal set, and we're told we have -10 and +10 here as our universal set. So before we even proceed, let me make an emphasis on this. So I have something like this and this. Now these two here means not part of, or not included. That's what these two means. And the other side means included or part of. So remember, when we have something like this where say x is greater than or equal to 1, x is greater than or equal to 1, it means 1 is part of x, so you start from 1, but when we don't have this, it's x greater than 1, so 1 won't be part of x, so start with the values which are greater than 1. So it's the case here. This means they are not part of. It's more like a similar situation, but this means they are part of, which can bring in this. Okay, so we'll work with these, and it's very important for you to understand when and when not to use them, right? All right, so let's proceed. So let's say this is our universal set, and we're given let's say set A, and that set A, let's say it ranges from -2 to +6, and set B, we've also been given set B, which will range from okay, let's say just for the sake of understanding, of something like this, which is -5 to, let's say, +3, and it's part of the set. And we also have C here, C, okay, for the sake of understanding as well, let's say the C, we have -1,8. Yeah, let's say we have something like this. Then we want to find, let's say the first question tells us to find the complement of A. All right, so remember that complement simply means the opposite, or the values which are not part of the given set. So here we're talking about the values which are not part of A. So to start with, we'll come up with a set which is the universal set, which will plot on the number line. Now remember that when you are plotting the number line, it goes from -infinity to +infinity, but here it's been restricted. We've been given a range of x, so to range from -10 to +10, right? To +10 and -10. Then we've been given some values here, so you don't really have to write the numbers in between here. So say we have -10 to 10, then we'll plug in the values that we have here. So we'll start with the negative values. We have -2, -5, and -1. So we have -5, -2, and -1 somewhere there. Then the positive values, we have 10, which is already there, and 6, 3, and 8. So we have 8 somewhere here, 6 and 3 somewhere here. We can have a 0 somewhere here. There's no harm in that. So this will be our universal set, our set X, right? So to plot these subsets which have been given, set A, B, and C. So set A will range from -6 to +6. Sorry, -2 to +6. So -2 is here, and according to the set, it shows that -2 isn't part of the set A. So we're going to have an open circle here, so to show that it's not part of the set, to 6, which is somewhere here, which isn't part of the set, and B will range from -5 to 3. So we have -5 here, which is part of the set, so we're going to have a closed circle, and it goes on to +3, which is also part of the circle. The same applies for C. We have -1, which is part of the circle, and it goes on to +8, which isn't part of the circle. So you can indicate to say this is our A, this is our A, this is our B, and this is our C. Here you would have shown or plotted the entire set. If you want, you can write these values on top. Now, the question says we find A complement, right? And after finding, we plot it on a number line. So we'll use this same number line that we already have to find A complement. So this is our A. And when we talk of A complement, we are simply talking about the values which are outside A. Okay, so we've got values from this side and values the other side. So this is our A complement. But how can we define this? So notice that this will go up to -10. So meaning this side you're going to have -10 comma up to where A starts from. Now 2 isn't part of A, meaning it's part of the A complement. So we're going to have -2 here, which is part of the A complement, and -10, which is part of the A complement. Right? We go to B. B, right? So pardon me here, the set here indicates that on the universal set -10 isn't part of the universal set, so we can't have a closed circle here. We'll have an open circle, yeah, something like this. So this will be one side of the set, and we also have the other side here. So say union, since there are two, so this one will start from -6 isn't part of A, meaning it's part of A complement. Sorry, +6. So we're going to have it's part of A complement. We're going to have 6 up to +10, which we're going to have an open bracket because it's also not part of the universal set. So here you would have shown or found your A complement. So this is your A complement. But how can you show this now on a number line? So you bring in here the universal set. So we've got 10 and -10 here. We have -5, -2, -1. We have 3, 6, and 8. So we just plot the union of this. So this will start from -10, which is not part of the set, to -2. -2 is somewhere here, it's part of the set, and you have +6 to +10, something like this. And this isn't part of the set, this is part of the set. So you would have plotted your A complement. So this is to your A complement. So here you've defined what your A complement is. So here you've defined, and here you've plotted your A complement. All right. Okay, so let's look at another question, the way it might be phrased. Pardon me, I don't have enough space, so I will erase this whole part which will solve the A. Okay, let me quickly erase. Let's say B says find x minus A. X minus A. So to find x minus A, you know that, so this will be 2. So x minus A is just the same as x intersection A complement, right? So looking at the information that we have, we're going to find the universal set where it intersects with A complement. Remember that the A complement ranged from -10 to 2. This was part of the A complement. And also this side, it ranged from 6 to 10. This was also part of the A complement. Now where this intersects with the universal set, so you simply have the same set, you get, right? So this will be the same set. This shows the intersection where these two meet. it means you're finding your intersection. So you've got your A complement here, which also extends to this side. Now where they meet with the universal set here, so that will be your intersection of X intersection A complement. So it also range from -10 to -2, which will be part of the set, and union we have 6 here, so it's part of the set to 10. So this will be your X intersection A complement. Alright, and if you were to show this on the number line, you'd just have the same number line that we had earlier, because there are no changes that have been made. Alright, okay, yeah, let's proceed by finding another question. Very important to draw the set, because we're going to use it to find almost all the questions that will require us to find the set. So we have a question, we might have a question which, so we'll say question 3, we find A intersection C complement. A intersection C complement. Now to find this A intersection C complement, we will first work with what's in the set. Remember, you've worked with the terms board mass and bead mass, so here bead mass will apply, and if you're not familiar with these terms, I'll drop the link in the description for you to make use of that and understand how to use them when and when not to apply. Alright, so we'll first find our A intersection C. So this is our A, the set here is our A, and our C is on top here. So where these two meet is the intersection. So you can have a line that connects these two for you to have the intersection. Now notice that where these two meet, it will start from where C starts from, which is -1, and it's part of the set, and it goes up to where okay, so it goes up to where A ends, which is 6, right, which is 6. So this is where the intersection ends from, and to check whether A is part, I mean 6 is part or not part of the intersection, you just have to realize or consider the set A. You know that 6 is not part of the set A, thus it won't be part of the intersection. So this will give you your A intersection C. Now we want to find the complement of this. So the complement of this, it means we'll consider the remaining values here. So the shading here was just to help us find the complement. Find the complement. Now we'll consider the values which are not part of the shaded area. That will be the complement of A intersection C. So since -1 is part of the shaded area, it means it won't be part of the complement. So it will range from -1 up to -10. So we're going to have -10 to -1, which isn't part of this, and you have this side and the other side. So we're going to have a union. So this will start from 6, which is not part of the intersection C, so it will be part of the complement up to 10, right, up to 10. So this will be your A intersection C complement. So if you start with what's in the bracket, things will be simplified and you'll be able to answer such kinds of a question. Alright, so let's quickly solve the last question, and showing this on the number line. Sorry, we almost left that out. So showing this on the number line, so I've got a 10 here, you've got a -10 there, then we've got your -5, -2, -1. You can have a 0 here, 3, 6, and 8. So it's a -10 to -1. It's here. They're all not part of the set. This is -10 to -1, and 6 to 10, 6 to 10. So this is part of the set. So you would have shown this on the number line. You've defined and plotted this on a number line. Alright, so let's quickly solve the last question. So this is our question. B intersection A complement intersection C. So first start with what's in the brackets. So B y intersects with A complement. So this is our B here, and our A complement is just the values outside A. So where these two intersect, so they will intersect. This will be the intersection up to here, and notice that this part we won't have an intersection because where B ends is like A is part of that. So this will be the only intersection. So we have -5 to -2. -5 is part of the set, and -2 is also part of the set, right? Now this is our B intersection A complement, where this intersects with C. So C starts from -1 to 8. So notice that here this is our B intersection A complement. We want to find where this set here, so we can write a line up to here to say that this is our B intersection A complement, where these two intersect. So notice that they don't have anything in common because they won't meet anywhere. Thus we're going to have an empty set because you can't shade where these two meet. You get, right? So our B intersection A complement, we're going to have an empty set. So how do you plot an empty set on a number line? That's an empty of nothing, so you can leave it here. So by this you would have defined the values and also plotted on the number line. So in the next video, pick it up from here and solve more questions on how to plot the sets on the number line. So this was a viewer requested video, a student from the University of Zambia. So you can drop your questions in the comment section and we can work on them. So thank you, and remember to subscribe.